Dear students, we will see today why inverse function exists only for a bijective function. Once again I repeat, why inverse function exists only for a bijective function. That is a heading. Now before that, let us see what do you mean by bijective function. You know, bijective function is a function which is both 1-1 as well as onto, both 1-1 and onto. Such a function is called as bijective function. And in bijective function, since it is both 1-1 as well as onto, since it is a function, no element of set A can be left out. Since it is onto function, no element of set B also left out, which clearly says that in case of bijective function, number of elements in set A must be equal to that in set B. This is the characteristic feature of a bijective function. Now once again, let us come back to the heading, why inverse function exists only for a bijective function but not for any other function. Let us take different cases, then you can understand better. Now we will take a case 1, a function which is only 1-1 but not onto, Say they are telling but not onto, so therefore say this is set A, this is set B, A1, A2, A3, A4, B1, B2, B3, B4, B5. Say A1 to B2, A2 to B1, A3 to B4, A4 to B5. You know that this is 1-1 function. There is no convergence. It is a function first of all, and then there is no convergence, therefore it has to be 1-1 function. But it is only 1-1, but it is not onto, because see, B3 is left out. Therefore it is not onto. If at all it has to be onto, every element of set B has to be considered. But B3 is left out, therefore it is not onto function. It is the example of only 1-1 function but not onto. And this is obviously F maps A into B. This is a function which is only 1-1 but not onto. Now let us try inverse relation for this, and we will check whether that inverse relation is a function. Okay, when you try inverse relation for this is set B, this is set A. Say I am trying to write inverse relation for this function which is only 1-1 but not onto. Here B1, B2, B3, B4, B5, and this is A1, A2, A3, A4. Say B1 to A2 and B2 to A1, B3 is not at all connected, B4 to A3, B4 to A3 and B5 to A4. This is not a function at all. This is not a function because the definition of function says that every element of first set must be associated. But B3 is left out in mapping, therefore this is not a function at all. Therefore, inverse function is not defined for a function which is only 1-1 but not onto. Next we will take another example where only onto but not 1-1. But not 1-1. Let us see. This is set A, set B, A1, A2, A3, A4, B1, B2, B3. A1 to B1, A2 to B1, A3 to B3, A4 to B2. Definitely this is a function but not onto. I am sorry, this is a function and it is an onto function. It is an onto function because no element of set B is left out. I repeat, this is a function and it is an onto function because no element of set B is left out. This is not 1-1 function because there is a convergence from set A to set B. This is not 1-1. It is an onto function but not 1-1. That is what I am writing. Consider a function which is only onto but not 1-1. Okay, let us try. This is represented by f maps a into b is a function which is only onto but not 1, 1. Now let us try to write inverse function for this. When you try to write inverse relation for this, say this is b, this is a, b1, b2, b3, a1, a2, a3, a4. b1 to a1, b1 to a2, this is enough to say that this is not a function, because divergence from first set to second set is not at all allowed. If at all it has to be a function. Uniqueness is lost here. Therefore, this is not a function. See, I have taken a function which is only onto but not 1, 1, and I tried to write an inverse relation for that, and you find that that inverse relation is not at all a function. That's why inverse function does not exist for a function which is only onto but not 1, 1. Now let us take another example. Set A, neither 1, 1, neither 1, 1 nor onto. Set A, set B, look at this, A1, A2, A3, A4, B1, B2, B3, B4, B5, A1 to B2, A2 to B2, A3 to B4, A4 to B3. Look at this. This is a function, no doubt. It's not 1, 1, because there is convergence from set A to set B. It's not onto because B1 and B5 of set B are left out. Once again I repeat, this is a function, but it's neither 1, 1 nor onto. Now try to write an inverse relation for this. How do you write? Say this is set B, this is set A. This is f maps A into B. I am trying to write an inverse relation for this particular function which is neither 1, 1 nor onto. Say this is B1, B2, B3, B4, B5, A1, A2, A3, A4. Say B1 is not at all associated. That is enough to say that it's not a function. Look at this. Inverse relation is always written on the basis of the existing relation. Existing relation is a function which is neither 1, 1 nor onto. I am trying to write an inverse relation for this. In the process, B1 is not at all associated. That is enough to say that this is not a function. And you can go ahead further. B2 is associated with A1 as well as A2. Uniqueness is lost. Therefore, this inverse relation is not a function, because there is divergence from first set to second set. See what is happening here. I tried a function which is only 1, 1, first example, only 1, 1, but not onto. Tried to write a inverse function for that. Inverse function does not exist. Then I took second example, which is only onto function but not 1, 1. Tried to write an inverse function for that, but inverse function does not exist. Then third example, a function which is neither 1, 1 nor onto. Tried to write an inverse relation for that. I found that inverse function is not at all defined for even for that function which is neither 1, 1 nor onto. So we are left out with only one type of function, that is both 1, 1 as well as onto. Let us see that case. Fourth case, bijective function which is both 1, 1, both 1, 1 and onto. Okay, look at this. This is set A, this is set B, A1, A2, A3, A4, B1, B2, B3, B4, A1 to B2, A2 to B1, A3 to, like this. This is a function, you know. And this is 1, 1 because no convergence. This is onto because no element of set B is left out. It is both 1, 1 as well as onto. Try to write an inverse relation for this. So if you try to write an inverse relation for this, this is B, this is A, B1, B2, B3, B4, A1, A2, A3, A4. Look at this. B1 to A2, B2 to A1, B3 to A3, B4 to A4. You find that this inverse relation is also a function, and you find that this is also a bijective function. You have considered a bijective function, means which is both 1, 1 as well as onto, and you try to write an inverse relation for that, and you find that inverse relation is also a function. Therefore, you can come to the conclusion that inverse function exists only for a bijective function, not for any other functions. Because we have taken the examples of all other cases, you found that inverse function is not existing for all other cases. But when you took the example of bijective function and tried to write the inverse relation, you found that that inverse relation is also a function. Therefore, you can come to the conclusion that inverse function exists only for a bijective function. Remember forever that inverse function exists only for a bijective function, not for any other function. This is a thumb rule. In order to study the inverse trigonometric function, you start from here. Entire inverse trigonometric functions, which is one of the important topic in mathematics, in trigonometry. The entire concept is based on this particular sentence, that inverse function exists only for a bijective function, but not for any other function. Inverse trigonometric functions. Okay, so the trigonometric functions, basically fundamental trigonometric functions, are sine, cos, tan. So accordingly, we will start with inverse sine function. Inverse sine function. As I have told earlier, that inverse trigonometric function, the entire topic of inverse trigonometric function, if at all you are going to understand the entire topic, it is based or it is pivoted on one particular result, that inverse function exists only for a bijective function, not for any other function. Once again I repeat, inverse function exists only for a bijective function. On the basis of this, we will try to analyze what in by sine function, and then we will try out inverse for that. Okay. Say, you consider sine function. Normally sine function, set A is angle, set B is sine of that. Set A is say x and set B is sine x. Or set A is theta, set B is sine theta. Okay, angle, any angle you can take. Any angle you take, sine of that angle is defined. Say, once again I come back, this is theta, this is sine theta. You take any angle, any real value for the angle if you take, then sine of that real angle, it exists between -1 and +1. It may be half or 0.8, it may be √3/2. √3/2 is 0.866. 1/√2, sine 45 is 1/√2. Even sine 135 is also 1/√2. Sine 135 is sine 45, supplementary ratios. Sine 45 is 1/√2. 1/√2 means 1.414. 1/1.414 is 0.7071. You take any angle, sine of that angle has to lie between -1 and +1. Sine answer cannot be more than 1, it cannot be less than -1. So, but angle can be anything. This is theta and set B is sine theta. Sine theta lies between -1 and +1 only. So, at the beginning only you have to restrict set B as a set which contains all the elements between -1 and +1. You can't write real number. If you write real number, then it will not be onto. Say if you write -2, -3 and so on, while mapping, -2 will not be considered at all. Even 2, 3 like that, if you write it as real number, any real number if you write, 2, 3 is also a real number. While mapping, 2 and 3 will not be considered, because sine of any angle cannot be 2. But still it is a function, because in a function some elements can be left out, you see, in set B. But if at all it has to be onto function, no element of set B can be left out. So you must be very careful while selecting set B. And on the basis of the ideas already which you have gained, say this will be between -1 and +1. What is this meaning? It's a closed interval, a set which contains all the elements between -1 and +1 inclusive. Okay. If you write like that, now let us consider it in the form of mapping. Set A, set B. Let me consider all the angles or representative angles in different quadrants. Say, let me select with 0. Let me take 30 degree. This is in first quadrant. And let me consider 90 degree extremity of first quadrant, then 150 degree second quadrant, then 180 degree, then 210 degree, then 270 degree, then we will consider 300 degree, 330, and then 360. No need to take so many angles, but let us take, not a problem. So almost all the angles, extremities also have taken 0, 90, 180, 270, 360. And 30 is in first quadrant, 150 is in second quadrant, 210 is in third quadrant, and 330 is in fourth quadrant. Instead of 330, you can take it as -30 also, absolutely not a problem. And here different angles like -1, -half, 0, half, and then 1. You could have written still more, say 1 by root 2, root 3 by 2, you can write. Okay, this is sine function, you know. Sine 0 is 0, sine 30 is half, sine 90 is 1, sine 150 is sine 30 again half. So no longer it is bijective because it becomes 1, 1. Sorry, it is not 1, 1 because there is convergence. It is not 1, 1, therefore it is not bijective. See, there is convergence from set A to set B. So therefore it cannot be 1, 1. Once it cannot be 1, 1, it cannot be bijective because bijective function definition says that it has to be both 1, 1 as well as onto. Here you find that this is not 1, 1, therefore it is not bijective. If it is not bijective, straight away say inverse is not existing at all. So if you define sine function like this, then inverse function is not defined for such a sine function. Then how to proceed? See, game becomes very interesting. Imagine inverse trigonometric function, inverse sine function is a game. And no game is interesting if you don't, define the rules for the games. Every game becomes very interesting when rules are defined for that. Here also, this is a high time to define a rule for sine function so that inverse is defined for that. Let us see. By trial and error method, if you take different possibilities, finally you take a set A. Now what happened here? You take set A, you have taken set A as real number set, any angle you have taken, and then try to define the sine function. Sine function is defined, correct? But if you define it like that, if you take a sine function like that, inverse does not exist because no longer it is bijective. Because the status of 1, 1 is lost here. It is not 1, 1, therefore it is not bijective. If it is not bijective, inverse does not exist. So our effort is to see that the original function, sine function, what you take, it must be bijective. Like that you have got to take. You take different options. Set A, set B is fixed because whatever may be the angle, sine value will not go above 1, it cannot be below -1. So adjustment is only with set A. What is that? We will take different angles. Say for example, if you take like this 0 to pi into -1, +1. One trial and error method. I am resetting set A. I am restricting set A to contain all the angles between 0 to pi inclusive. What happens? Let us see. This is set A, this is set B, 0 to pi, 0, 30 degree, 90 degree, 150 degree, 180 degree, and here I will take -1, say -half, 0, half, 1. Sine 0 is 0, sine 180 is also 0. You know, everybody knows sine 180 is 0. It is as good as everybody knows, means at this stage, it is as good as knowing everybody knows what is their right hand. There should not be any confusion. Similarly, sin 180 is equal to 0, you should not have any confusion. If you have confusion, further things you can't study. That you already come across in first PU. Okay. Say, see, this is enough. Even sin 30 is half, sin 150 is also half. This is enough to say that it is not bijective. No longer it is 1, 1. If it cannot be 1, 1, it cannot be bijective. So inverse function does not exist. Like that you go on trial and error method. And you find that most of the cases you find that inverse does not exist. Because no longer the function what you are taking originally, it will not be bijective. If it is not bijective, inverse function does not exist. Then trial and error method. Earlier mathematicians have tried and we are not trying so much because they already tried, and what they have succeeded, that we will take right now. So one particular case, sine function mapping, set A contains all the elements between minus pi by 2 to plus pi by 2, and set B contains all the elements between minus 1 and plus 1. Let us see what happens. Set A, set B, this is minus 90, I am writing in degrees, minus 30 degree, 0, then 30 degree and 90 degree. I have taken like this, minus 1, minus half, 0, half and 1. And this is x, this is sin x, or theta, sin theta. This is sine function. Sine of minus 90. Sine of minus 90 is sine of minus theta, minus sin theta. Sine of minus 90 is minus sin 90, minus 1. Sine of minus 30, minus sin 30, minus half. Sine of 0, 0. Sin 30, half. Sin 90, 1. If you take set A like this and set B like this, any two angles in set A you take, sine of those two angles will not have same answer, which clearly says that it is 1, 1. No two elements of set A will have the same image in set B, which clearly says that it is 1, 1. Then any value between minus 1 and plus 1 if you take, that is the image of one element of set A. Say for example, if you take root 3 by 2 here, root 3 by 2 obviously it comes here, this is 0.5, this is 1, root 3 by 2 is 0.866. So root 3 by 2 is the image of 60 degree. And root 3 by 2 is not the image of two angles of set A, no. If you take set A like this, root 3 by 2 is the answer of only sin 60. No other angle between 0 and minus 90 and plus 90 will have the answer root 3 by 2. Only 60 has, which clearly says that between minus 1 and plus 1, any value if you take in set B, any element if you take, then that is the image of one element of set A between minus 90 and plus 90, which clearly says that this is onto. Already said it is 1, 1. And now I am telling it is onto. It is 1, 1 as well as onto. Hence it is bijective. So inverse has to be defined for this. And if you write the inverse, then inverse exists for this. So if you consider like this, inverse exists. Inverse exists. Then how do you write that inverse? You see, inverse will be like this. Set B and this is set A. This is minus 1, minus half, 0, half, 1. And here minus 90, minus 30, 0, 30 degree and 90 degree. And this is x and this is sine inverse x. Inverse is existing, no? I wrote. So that is sine inverse. Okay, this is x, this is sine inverse x. Look at this, minus 1, minus 90, minus half, minus 30, 0, 0, half, 30 degree, 1, 90. So you find that inverse function exists, and inverse function is also a bijective function. That is quite obvious. For a function, means for a bijective function, inverse is defined, and that inverse function, whatever is defined, that is also bijective. So therefore this is written as sine inverse mapping set B to set A, set B to set A. What is this set B? It's a set which contains all the values between minus 1 and plus 1. And what is set A? This is containing angles between minus pi by 2 and plus pi by 2. Say this is x and this is sine inverse x. Note here that x is all values and sine inverse x, they are all angles. One important sentence you need to remember. I said earlier, inverse function exists only for a bijective function. Remember forever, I said. Similarly, one more sentence you need to remember forever. Answer of inverse trigonometric function is always an angle. Sin inverse something, it's an angle. Cos inverse something, it's an angle. Tan inverse something, it's an angle. And if I ask, who is Sachin Tendulkar? Cricketer. Virat Kohli? Cricketer. You can't say human being, that is understood. By default, it is understood. But you have to be very specific. What is sin inverse something? Angle. What is cos inverse something? Angle. So you must keep it in your mind that answer of inverse trigonometric function is always an angle. You can express in degrees or you can express in radians. That doesn't matter. But answer of inverse trigonometric function is always an angle. This sentence is as important as the sentence that inverse function exists only for a bijective function. Once again I repeat, how inverse function exists only for a bijective function, how much important is that sentence to learn entire inverse trigonometric function. Similarly, most important sentence to proceed in inverse trigonometric function is answer of inverse trigonometric function is an angle. Sin inverse something, angle. Cos inverse something, angle. Tan inverse something, angle. Secant inverse something, it's an angle. Cosec inverse something, it's an angle. Cot inverse something, it's an angle. That angle you can express in radians or degrees. This will avoid lots of confusion in the future when you get into the subject more and more. Okay. So you understood. This is first set, this is second set. And this is the domain, this is the range for this inverse trigonometric function. Domain and range. You find that answer of sin inverse exists only between minus pi by 2 and plus pi by 2. Look at this. This is, I said answer of inverse trigonometric function is an angle. Sin inverse something is an angle. It cannot take any value. So never ever think that sin 30 is equal to half. Therefore, sin inverse half is equal to 30 degree. This is true. Correct. Sin 150 is also half. This is right. This is right. This is also right. This is right. But sin inverse half is not equal to 150 degree. No, this is wrong. Means it cannot be equal to 150 degree. Sin inverse answer must be only one. See, inverse trigonometric function is also a function, no? So answer of sin inverse half, you can't have two answers. You must have only one answer. If there is no uniqueness, how can it be called as a function? So that's the interesting part here. You find that minus 1, comma plus 1 is the domain. This is a set containing all the elements between minus 1 and plus 1 is the domain. And a set containing angles between minus pi by 2 to plus pi by 2 is the range. And which clearly says that sin inverse x angle can roam between, what is that, 0, not here, sorry, between minus pi by 2 to plus pi by 2. This is the kingdom of sin inverse x, you can say. Sin inverse x always lies between minus pi by 2 to plus pi by 2. Look at this. Answer of sin inverse x must be an angle between minus pi by 2 to plus pi by 2. And x can lie between minus 1 and plus 1. Look at this. This is x, this is sin inverse x. And this is a function, sin inverse. So remember forever, on the base of this analysis, you find that sin inverse x is an angle between minus pi by 2 to plus pi by 2, where x lies between minus 1 and plus 1. This you need to remember. This is the most important sentence which you need to remember. Sin inverse x is an angle between minus 90 and plus 90 only. If somebody says sin inverse x is 120 degree, impossible. Never ever sin inverse answer can be 120 degree. No. Under extreme circumstances also, answer of sin inverse cannot be 120 degree. Answer of sin inverse is 210 degree. Impossible. Answer of sin inverse something is equal to 30 degree. Possible. Sin inverse something is equal to minus 45 degree. Okay, correct. Answer of sin inverse is equal to 315 degree. No. Then you may ask one question, sir, 315 degrees in fourth quadrant, sin inverse answer can be in fourth quadrant. No. No. Sine inverse answer can be between minus pi by 2 to plus pi by 2. Just because minus 45 degree lies in fourth quadrant, you can't say that answer of sine inverse can be an angle, any angle in the fourth quadrant. No. Say 315 degrees in fourth quadrant, but sine inverse something answer cannot be 315 degree. Because this analysis says that answer of sine inverse must be between minus 90 and plus 90 only. 315 if you say it is more than 90. It's not just the quadrant, the value what we have written, that is very important. Okay. So you remember sine inverse, and further if you observe, this is x and this is sine inverse, this is x, this is sine inverse x. Okay. X values you can classify into two categories. One is negative values of x, another is non-negative values of x. Roughly you can say positive, but non-negative need not be positive. 0, which is non-negative, but it is not positive. But roughly when we say it is classified 0 also, we include it in the positive category because it is not negative. This is x being negative, this is x being non-negative. Accordingly you find that this answer is in fourth quadrant, this answer is in first quadrant. On the basis of, anyways you have written this, sine inverse x lies between minus 90 and plus 90, where x lies between minus 1 and plus 1. You can split it. If x is greater than or equal to 0, see, x is greater than or equal to 0, means when x is positive, then you find that sine inverse x is in first quadrant, 0 to 90. So first quadrant, how do you write? Sine inverse x is less than or equal to 90 degree and greater than or equal to 0 degree, which clearly says that if x is positive, sine inverse x is in first quadrant. Sine inverse x is an angle? No. Angle means it has to be one of the quadrants. If x is positive, then sine inverse x is in first quadrant. First quadrant angle, how do you write? Between 0 and 90. If x is positive, sine inverse x is an angle in first quadrant. And second part you see, if x is negative, then sine inverse x, where do you find? This is in fourth quadrant, minus 30, minus 90. Fourth quadrant is less than 0 degree, greater than or equal to minus 90. Or you write it in radians, you know. Okay, anyways you have written in degrees, so write in degrees only here also. Minus 90 degree. Look at this. And in fact, this is a representation of fourth quadrant angle. When x is negative, sine inverse x is in fourth quadrant. Fourth quadrant, how do you write? Less than 0, greater than or equal to minus 90. Less than 0, greater than or equal to minus 90. So this is very, very important. If x positive, sine inverse positive, first quadrant. If x is negative, sine inverse negative, fourth quadrant. So remember, out of this discussion, sine inverse positive, sine inverse is an angle. Sine inverse positive, first quadrant angle. Sine inverse negative, fourth quadrant angle. Absolutely no confusion. Sine inverse of something, 60 degree, okay. Sine inverse of something, minus 45 degree, okay. Sine inverse of something, 120 degree, not okay, because answer of sine inverse cannot be in second quadrant. Answer of sine inverse cannot be in third quadrant. Answer of sine inverse has to be either in first quadrant or in second quadrant. No, either in first quadrant or in fourth quadrant. This analysis says that if x is positive, sine inverse x is in first quadrant. If x is negative, sine inverse x is in fourth quadrant. Very, very important. Say a lot of examples you have. Sine inverse 0 is equal to 0. Sine inverse half is equal to pi by 6. Because sine pi by 6 is half. What care you need to take here is answer of sine inverse what you are writing either in first quadrant or in fourth quadrant. That care you have got to take. Sine inverse of 1 by root 2, that is equal to pi by 4. Sine inverse of root 3 by 2, that is equal to pi by 6. And sine inverse of 1, that is equal to pi by 2. Look at this. Answer of inverse trigonometric function. All x values are positive. So angle, sine inverse answer is an angle which is between 0 and 90. Now let me take the other example. Sine inverse of minus half. Minus half. Sine in minus half is negative. Sine inverse of negative, we have seen, no? Sine inverse negative is in fourth quadrant. So fourth quadrant, that's equal to minus pi by 6. Sine inverse of minus 1 by root 2. Sine inverse of negative. Sine inverse negative has to be in fourth quadrant. That's equal to minus pi by 4. Sine inverse of minus root 3 by 2. Sine inverse negative has to be in fourth quadrant. That's equal to minus pi by 3. Sine inverse of minus 1. That's equal to minus pi by 2. Say x values are all negative and sine inverse x is an angle in fourth quadrant, you see, between 0 and minus 90. And if you observe closely, if you observe that particular analysis, then you find that, say for example, sine inverse of minus half. You have written minus pi by 6. Minus pi by 6. That's equal to, sine inverse of minus half is minus pi by 6. And at the same time, this is nothing but sine inverse of minus half is minus sine inverse half. Or let me give it as an example. In general, when you observe, see, this is sine inverse k, this is sine inverse minus k. And if you compare the answers, you find that pi by 6 minus pi by 6, pi by 4 minus pi by 4. And this is not pi by 6, I am sorry, this is pi by 3. Sine inverse of root 3 by 2 is pi by 3 and minus root 3 by 2 is minus pi by 3. Based on that comparison, you find that sine inverse of minus k is equal to minus sine inverse of k. Whatever minus sign you have now, you can take it outside. Say example we will take up. Sine inverse of minus root 3 by 2 is equal to minus sine inverse root 3 by 2, that's equal to minus pi by 3. Sine inverse negative is an angle in fourth quadrant. So this is about inverse sine inverse function. Let us try to draw the graph, no? That will give you the clear picture. Say I am trying to draw the graph of say this is sine inverse x and this is x. Graph of sine inverse x versus x. You have a restriction for x values. X values must lie between minus 1 and plus 1. I said inverse trigonometric function is like a game. And game becomes very interesting when you introduce rules for that. We already introduced rules. In sine inverse x, x must lie between minus 1 and plus 1. And sine inverse x must lie between minus pi by 2 to plus pi by 2. With these rules, only how to play the game. So x must lie between minus 1 and plus 1. Say 1 and minus 1. Okay, plus 1, minus 1. Entire graph must lie between these two vertical lines. X cannot be more than 1. X cannot be less than minus 1. And you have condition on sine inverse x also. Sine inverse x is an angle, but it cannot be more than pi by 2. Look at this. It cannot be more than pi by 2. It cannot be less than minus pi by 2. So you have got horizontal lines also. This is pi by 2, this one, this is 0, and this is minus pi by 2. Look at this. So entire graph of sine inverse x versus x must lie in this particular so-called rectangle. Light lines, not this is thick line, this thick line, these are all construction lines, light lines. Okay, so if you take the example, let us see, sine 0, sine inverse 0. Sine inverse 0 is 0, 1 point is here. Then sine inverse 1, you know that it is pi by 2. Sine inverse minus 1, minus pi by 2. And you have got so many values in between. Say if you take sine inverse half, half comes here. Sine inverse half is equal to pi by 6. Sine inverse half is equal to pi by 6. Pi by 6 is an angle somewhere here. See, if it is pi by 2, this is 0, this is 90. So 30 is 1/3 of that here. And if you take one more, root 3 by 2 if you take, you will get 0.8, root 3 by 2 if you take, you will get pi by 3. Pi by 3 60, 60 comes here. And if you draw the graph will be like this. The graph must be in such a way that, see, you may ask one question. Sir, you have written the graph like this, like this, like this, like this, like this. Then connecting between this, then I have connected like this. Right? Then you may argue, why not like this? This is wrong, absolutely. You remember this particular sentence. Later, while doing a topic in applications of derivatives called tangents and normals, if you remind any teacher who is teaching you, let it be me or anybody, you just remind them, sir, can you take the reference of sine inverse, cos inverse graph? Why the graph has to be like this? Why not like this? The difference is, if you draw the tangent here, it will be parallel to x-axis. If you draw the tangent here, it is perpendicular to x-axis. And here it has to be perpendicular to x-axis. Therefore, that's why graph is like this. You can get a very clear idea when we do the topic called tangents and normals. So, remind your teacher to explain more about why the graph of sine inverse x versus x has to be like this, but not like this. Then you can understand better. For the time being, you understand the tangent which is drawn at x is equal to 1. At this particular point, if you draw the tangent, it must be perpendicular to x-axis. It cannot be parallel to x-axis. If you draw here, if the graph is like this, if you draw the tangent, it will be parallel to x-axis. But if you draw, if the graph is like this, the tangent is perpendicular to x-axis, and the tangent has to be perpendicular to x-axis at this particular point. So, this is the graph of sine inverse x versus x. You can write what is the domain for that. Can you tell what is the domain? Come on. Domain means the values of x which can participate in that particular function. What is that? 1, 2, 3, 4. Tell. Yes, it is between -1 and +1. This is the domain. These are the only values of x which can take part in that particular sine inverse function. Then what is range? Range means the values of sine inverse x, possible values of sine inverse x. It is very clear. Any value between -π/2 and +π/2. -π/2, +π/2. Closed interval -π/2, +π/2. This is about inverse trigonometry, sine inverse sine function. What you need to remember out of this discussion is, sine inverse function, sine inverse x exists only when x lies between -1 and +1, and sine inverse x is an angle between -90 and +90. Further, sine inverse positive, answer is first quadrant angle. Sine inverse negative, answer is fourth quadrant angle. I repeat, sine inverse answer is an angle. Sine inverse x must lie between -1 and +1. And if x is positive, sine inverse positive is first quadrant angle. If x is negative, sine inverse negative is fourth quadrant angle. With this mindset, you can go ahead with the next, that is inverse cosine function, that we'll see slightly later.